Hi friends, good morning. Welcome to my channel Roy Formulation. Here we are discussing about quadratic congruence of composite modulus and modulo a product of two different odd primes. Now today we are considering in continuation this quadratic congruence, that x square congruent to a square mod pq. PQ are two different odd primes where P is smaller than Q, but here Q is equal to P plus 2. P plus 2. When this, between the two, one of the congruent prime is 2 higher than the first. That means their difference mod P minus Q is always equal to 2. That is, difference between the primes is 2. In that case, we say the primes are twin primes. Primes are twin primes. Twin primes. That means if PQ are two odd primes and modulus of their difference is 2, then we say the primes are twin primes. Means we can also, if P is a prime, the next prime will be P plus 2 and this product becomes a pair of twin primes. That means their difference is 2. That is the mention here. So here our congruence is x square congruent to a square mod product of twin primes. Product of twin primes. So clear idea what is twin primes? When PQ are odd primes and difference between the two primes is 2, then we call the primes are twin primes. So our consideration is this congruence, x square congruent to a square mod PQ modulo a product of twin primes. Now the formula. Formula for their solutions. Solution of this quadratic congruence, that x is congruent to plus minus a. X square congruent to a square. Then it is square root plus minus a are the two solutions, and remaining two solutions are plus minus p plus 1 into a. Here p is the first prime, Q is the second prime, and P plus 1 is the number between P and Q, because Q is equal to P plus 2. So in between P and P plus 2 there will be a new number which is P plus 1, and that middle number of P and Q multiplied by A. These are the two other solutions. In this way, this gives the 4 solutions of this quadratic congruence. Mod PQ. These are the solutions of this quadratic congruence. When you are x square congruent to a square mod PQ, PQ are twin primes. These are the 4 solutions, because such type of quadratic congruence is always solvable and it has 4 solutions. These are the 4 solutions. You have to memorize this formula. Which one? The square root of this number in the plus minus, and then the square, then the number between P and Q, that is P plus 1 into that A. This gives the other 2. In this way, these are the 4 solutions of the quadratic congruence. Let us consider a problem that solve x square congruent to 4 mod product of 17 into 19. We know 17 it is a prime number, 19 is also a prime number. The difference between 17 and 19 is 2. See, 19 minus 17 is 2. That means 17, 19 they are a twin primes. So it is all of the time x square congruent to a square mod PQ. Here P is 17 and Q is 19. it can be written as practical solution. Given number congruence is x square congruent to 4 mod 17 into 19. It can be written in this way that x square congruent to 2 square mod 17 into 19. It is of the type of the congruence is x square congruent to a square mod pq with mod p minus q is equal to 2. See, 17 minus 19. And therefore, the 4 solutions are given by this formula. Formula is x is congruent to plus minus a, and that plus minus p plus 1 into a mod pq, and substituting the values, it is plus, and our a is 2 here, so plus minus 2, and there is plus minus. P plus 1 is number between 17 and 19, that is 18, so that will be 18 into 2 mod 17 into 19, and totally that is 2, and it is 17 into 19 minus 2, and 18 into 2, 36, plus minus 36 means 36, and it is 17 into 19 minus 36 mod 17 into 19. In this way we can find the solutions. The solutions are then here it is 2, and product of 17 into 19 is 323 minus 2, and that is 36. That is 323 minus 36 mod 323, and the last answer, that is 2, and 323 minus 2 means 321, and that is 36, and 323 minus 36 is 287. 287 mod 323. These are the 4 solutions. See how easily the solutions are obtained. No other extra calculation, only put the values of P, Q and A in this formula, we will get the solutions. This is our Roy formulation. Let us consider one more problem as solve x square congruent to 225 mod 1763. In the solution, these are given congruence x square congruent to 225 mod 1763. This congruence can be written in this way, that 225 is square of 15, so you can write x square congruent to 15 square mod. Now 1763 can be factorized as a product of two factors, that 41 into 43. We know 41 is a prime number, 43 is also a prime number, and difference between the two is 2. 43 minus 41, 2. So definitely they are twin primes. So it is also a quadratic congruence, standard quadratic congruence modulo, two product of twin primes. That is, so that congruence is of the type x square a square mod pq, of the same type. And such type of congruence always has 4 solutions. It has 4 solutions. Then what are solutions? Here we are deriving these 4 solutions by a formula derived by Professor Roy. That's called Roy formulation. So by Roy formulation, the solutions are given by this. That x equal to plus minus a means plus minus 15 and plus minus the middle number between 41 and 43 is 42. 42 into that a is 15. So total value will be plus 15 means 15 minus 1763 minus 15, that means 1748. So one is 15, other is 1748. And next here, product of 42 into 15 is 630. So there is plus minus 630 means one is 630, other is 1763 minus 630, and this gives 15, 1748 and 630 and 1133. Mod 1763. So these are the 4 solutions. That means if we know the Roy formulation, use Roy formulation, we can find the solutions orally also. If we know the formula, we can obtain these solutions. We no need to use pen and paper. So that is about Roy formulation of solving standard quadratic congruence of this type. Whenever modulus is a product of two twin primes. Product of twin primes means difference between the primes is 2. They are called twin primes. This is a special case. Whenever x square convert to a square mod pq mod p minus q is 2. This is a standard quadratic congruence modulo product of twin primes. And then it has 4 solutions given by this formula. Formula is plus minus a, 2 solutions, and other 2 solutions given by plus minus p plus 1 means the number between p and q into that a. That between 41 and 43 is 42. That 42 into 15. Their product is 630. That is plus minus 630 and plus minus 15. These are the 4 solutions of this congruence. And simplifying, we obtain these are the 4. They are 15, 1748, 630 and 1133 are the 4 solutions of this quadratic congruence. Okay. So this is the solve x square congruent to 9 mod 899. Now this 899 can be factored as a product of two twin primes as 29 into 31. And definitely 29 is a prime, 31 is also a prime, so their difference 31 minus 29 is 2. Means these are twin primes. This is a quadratic congruence, standard quadratic congruence of composite modulus modulo a product of twin primes. Primes are 29 and 31. Definitely that 9 can be written as 3 square. 9 can be written as 3 square. So it is x square congruent to 3 square mod 29 into 31. So these will be 4 solutions. 2 solutions will be plus minus 3. And other 2 solutions definitely plus minus. The middle number of 29 and 31 is 30. 30 into that number 3. So these are the 4 solutions. You have to use the Roy formulation and then you get direct these 4 solutions. Let us try to calculate it as your homework. Okay. Thank you.